Hello, everyone. Welcome to our .NET Foundations Pittsburgh .NET user group. So you could follow us in meetup.com, pgs.net, and our social links are available. Feel free to follow us, and we have meetups running every single month. And today we're going to look into building intelligent apps with Semantic Kernel. We have our seasoned speakers, Adrian Wright and Jorge Balderas from Microsoft, based out of Pittsburgh location. Hey, welcome.
Hello. Thank you, Bella, for the introduction. So yeah, excited to be here talking about building intelligent apps with Semantic Kernel. My name is, well, one second, sorry, wrong screen. There we go. Yeah, so my name is Jorge Balderas. I'm a senior cloud solution architect in app innovation with Microsoft. Based out of Pittsburgh. I've been working in consulting in app development, cloud, and then more recently in AI. So it's yeah, great to be here. And Adrian, do you want to say hi?
Yes, hello everyone. My name is Adrian Wright. I'm also a cloud solution architect with Microsoft. I've been a developer here in Pittsburgh for around 20 years. Also worked with Jorge at Summa, a consulting company, and most recently, before Microsoft, worked at Zoll, cardiac management solutions in Fox Chapel, and excited to talk about AI apps with Semantic Kernel. Thanks for coming.
Thank you. So here's what we're going to cover. We're going to start. I'm going to do a brief overview on Semantic Kernel, just touch on a little bit of the concept for those who are not familiar. And then I'll do a little bit overview of the a workshop that we've built for it's available for public consumption, so you can follow along on your own time after the workshop. And then I'll turn it over to Adrian, who will do a demo, and then open up for questions. But obviously, I mean, you can you know, share your questions in the chat at any time. So let's start. So what is Semantic Kernel? So Semantic Kernel is an open source framework. So it's an SDK that lets you augment your applications with AI models. So you can tap AI from your code. And it can be used with different models. It's not just limited to OpenAI. We have you know, the popular models that you may recognize here from Google, Gemini, Hugging Face, Mistral, Llama, and more to come, obviously. The framework is available for development in C#, in .NET, and Python as well. There is an option in Java, but it's not at the same feature parity as it is with between C# and Python are. It is used internally by Microsoft, and it's also used by many of our customers. So one important concept of Semantic Kernel is something called plugins, also known as functions, so kernel functions. And plugins, you have essentially gives you the ability to expose functionality that you already have available in your code, like let's say like a REST API, or you're consuming a service, and you want to expose that knowledge to your model, rather than you using like a vector database. You're essentially given leveraging like a RAG, a retrieval augmentation pattern, but tapping into your functionality. But it's the same idea, the same pattern that you could do with your data is the same thing you can do with APIs and coding, essentially any code in your application. And it is exposed as a kernel function. You will see that on the demo, and it lets you leverage it from any of your like this .NET or Python applications, and you can build as many plugins as you want, right? As you need to augment your model with that particular functionality. So planners is another important concept from Semantic Kernel. And planners is really kind of like the kernel of Semantic Kernel, right? It's the heart of Semantic Kernel, because it's one of the things that decides to it will look at your plugins that you're exposing within your code, and it will decide, like, based on the capabilities that you're exposing, when should I use any of these additional functions in addition to whatever's available in the model. So that's what Semantic Kernel will do for you. It essentially serializes those plugins, sends those capabilities to the model, and then the model decides based on whatever is being asked to do, whether it should tap into those functions or it should just go to the LLM, or any combination of the above, right? And if it decides to use one of your plugins, you can see in the flow in like number 4 how it's actually going and invoking your function, getting a response back, feeding it back to the model, and then it's like kind of like looping, iterating through that as many times as it needs, depending on the plugins that you're making available. How it accomplishes that is using something called function choice behaviors, and also we'll show that in the code. And really the main one, the main behavior that you want to leverage in most cases is going to be the auto function, right? Because that's really giving you the same kind of like a AI or Semantic Kernel, like throws you that you can decide what's the best plugin to use for this particular scenario. And it works really great. I mean, we'll show that in the demo. We have a couple plugins, something very simple to just give time awareness to the model, like what time it is, and something a little more advanced to give, like, provide like stock pricing information, right? And you can, obviously, those are things that the model cannot do, so we're augmenting the model by giving those functions to our application. And the kernel will, like I said, it will mix and match between those plugins and decide which ones it should use. The other two behaviors that we have is require function. I mean, that's really if you want to always make sure it's using certain function or functions, you can also use that. And then the last one, none, this is really more for testing. Like, it does a dry run, so you can see what it would do, what it would decide to use. So that's really more like a testing capability. In terms of filters, that's another capability from Semantic Kernel. So it is a way to intercept the either at the prompt level or at the function execution level. So the example that I mentioned, that we're going to call a stock API to get pricing information. I mean, that service could go down. Hopefully, it doesn't go down in the demo, but it could go down, right? Things happen, and then that's where you can decide. You can use filters to essentially provide an alternate behavior. So you can maybe implement a retry if it makes sense, or you can implement caching, right? But that's another important consideration. Like, every time you're invoking these functions, that's adding time to the response time. So caching is something that could help reduce that processing time. You can also use filters to intercept the prompt. That's going back to the responsibility principles, a way to make sure that private information is not being shared, and then just put filters on the prompt. But it's another level where you can implement semantic caching, right? So that's another way where you can say, oh, I already saw this prompt, I already know the answer. Let's just grab it from the cache, as opposed to even like going against the model. So that is one capability where you can leverage prompt filters. And then the last one is in the auto function invocation, which is really if you want to override the auto function behavior. I mean, in some cases, maybe you decide there's a particular use case where you don't like whatever it's deciding to do. You can just say, override it and do X, Y, C. I haven't run into that, but I mean, that is there available for if you have that particular use case. So we're also going to show agents. I mean, it's hard to talk about AI without hearing about agentic AI these days. So agents are really the same concept of like functions, but they have these they're very goal oriented. Sometimes they have a very specific goal in mind. Agents are also used when you want to have collaborations. So you have agents that, like I said, they're meant to be very specific tasks, but you want to collaborate between those agents. And you can also leverage them for like autonomy or decision making. The two agents that are built into Semantic Kernel are the chat completion agent. This is very similar to the chat-based interaction that we'll show you, but you can give it, like I said, a very discrete goal and task that you want it to perform. And you can tab in. It works with any of these AI connectors that I mentioned, the different agents available for you. And then there's the OpenAI Assistant Agent. That's, again, very similar, but it adds 2 additional capabilities, code interpreter and file search. Now, it's worth pointing out that this framework, it is actually currently in preview, but it will be GA by the estimate date is by end of this quarter. So hopefully very soon it will become general available. And I also want to talk about Azure AI Foundry. So for those that are maybe new to doing AI within Azure, AI Foundry is one of the flagship services that we have available. So it's really a stack of gives you tap into different models that are available. Like obviously we obviously heard in the news about DeepSeek, that's available as the most other popular ones, and the different versions that are becoming available. Azure AI Foundry lets you consume those models, and it gives you all these ancillary services, right? Azure Search AI is very, very powerful. I've used it for makes it very easy to, if you don't want to implement your own vector database, very easy to index documents and then enhance your AI models with Azure Search AI. And then it is very confusing with all these different services. Like even for those that are within Microsoft, like it's very hard to keep up to date in general in the industry these days. But just in the context of Azure, these are all kind of like the main services that we have available. So looking at this, and it's kind of like upside down, but if we're thinking of like what we're going to show you is the semantic kernel. So that's kind of like thinking building AI applications from a bottom-up approach, where the bottom is you're starting writing code to tap into the models and exposing that in your application, versus a top-down approach where you can also start from the Azure AI Foundry services, and the Azure AI Foundry gives you a portal where you can go, and Adrian will show this, where you can go into and build like a chat playground and play, experiment with the chat or experiment with agents as well. So you have those options available, and then from that you can take that and deploy it. So it's not just like a playground. You can actually take that and deploy. So you can start from there. And a recent capability or SDK that was announced, I think around last October with Ignite, was the Azure AI Foundry SDK, which also gives you agents capability, like the option to develop your own agents either through code or from the portal. So the difference is that Semantic Kernel gives you that orchestration, whereas Azure AI Foundry, it's more. There's some orchestration you can build manually, but they're also compatible. So you can use semantic kernels. You can call specifically Azure AI Foundry agents as well. And that's actually one of our demos that we have today, where we can tap into grounding with Bing. So the only last part that we won't show today is AutoGen. That is more like a research SDK that is available. So typically, like the new features will be available in AutoGen first, and then once they mature, graduate to Semantic Kernel. Semantic Kernel is, as it says here, is really meant for production level applications. So if you want to put this in your applications, you want to look into Semantic Kernel. But if you just want to experiment with the latest and greatest, AutoGen may be a better place to start with. And then turning into the workshop. So this workshop is available for public consumption. I have the link on the next slide. And it lets you build. It shows you how to build a multi-layer application. So you can deploy a deploy application. But it also has lessons that starts with the basics of semantic kernels. We currently have 6 lessons, and they'll build on each other, right? So you can start with the very basic if that's where you want to start, or if you already know a little bit of a semantic kernel, you can skip the first lessons and go to the more challenging ones, depending on your level of experience. And then at the end of that exercise, you can actually take that and then deploy this whole, take those components and deploy it in a multi-layer application. So we'll have a simple web UI, like a chat agent this is built in React. And then we'll also have an API. That's the one that's using semantic kernel. And both of these are deployed as Azure container applications. And the API is the one that talks to this third-party service, Polygon.io. You can sign up for a free account. It doesn't give us like in the demo that we'll show today, or if you run this, it will give you like yesterday's data information. Just be aware of that. Unless you pay for the premium or the paid service, then you can get like today's data. We'll use Azure OpenAI as our model, and then we'll use the Azure AI Foundry SDK for building agents that will leverage the ground with Bing resource. Now, all of these, we also provide an Azure ACD, Azure Developer CLI, which is a way that you can, with one command, tell it to build the application, package it for deployment as a container image, build and provision all these resources that are needed in Azure using Bicep templates, and then deploying these components into the deploying the code into Azure. And that's that's done through ACD. Obviously, you need an Azure subscription. If you don't have one, you can sign up for a trial, or if you have your own, then you're welcome to try this at your own leisure. Here are the links: copilot.wksp.com. That's module 5. And then that link will point you to the GitHub repo at the top. And then this is what the deployable application looks like. And with that, I'll turn it over to Adrian for the.
Okay. Before we move on, Jorge, we have a couple questions in the chat. First is whether we can use RAG with data in our database with Semantic Kernel.
Yeah, absolutely. So on Semantic Kernel, if you go to the link that was almost in all of these slides, maybe a little, the aks.ms / this will take you to the Microsoft Learn site, but there is a GitHub repo, and I can put it on the comments as well, where you can look at the examples, and definitely one of the examples is using RAG, and then obviously you can do that with any data sources. I forget which one they're using that example. There's probably multiple examples that you can look into that, so that's a good reference.
All right, and there's another question about having humans in the loop intercepting a response from the LLM.
Yeah, so that's we don't have the agent collaboration as part of the demo. There is a couple of that, and in that agent collaboration, so the distinction with agents is that you can interact with users or it's agents, users, or any combination of that. So yeah, you would define your strategy or a collaboration strategy, and one of the options is to allow that human interaction, and that's where you have to define certain conditions. Like there's the typical example is that I've seen most days is the reviewer, right? Like you write something and somebody reviews it. So that can be done through like agent collaboration, but you can also request like a termination from a user where you can be a human can be the ultimate the last approver on that cycle as well.
Okay, I will share my screen and we'll get started with the demo. All right, so you should all be able to see my Azure portal here. I will start with some resources that I created as prerequisites for this workshop. The first is an Azure AI Foundry project. We'll jump into the Foundry UI in just a minute. I also created a workshop, Bing grounding resource. I was using different fruits and vegetables here every time I deployed, so we got the carrots one. This Bing grounding resource we will use when we are doing the grounding at the end of the workshop. But just wanted to show that you need to create some resources here in the portal, and then we can launch the Azure AI Foundry Studio here. And as Jorge said, this is where you can deploy LLM models. There's many models that you can choose from, OpenAI or Meta's models or DeepSeek. There's many you can choose from here. I have an OpenAI GPT-4o model deployed that we'll be using for this demo. And you can play with different chatbots. You can interact with them, tweak the settings, keep playing with it. You can also play with agents, and you can connect the agents to different resources. So for example, I have a connection to that Bing resource that I created, and that will enable us to do some grounding with the Bing search later on in the demo. But this Foundry is for development, but also for hardening and production support. There's tracing, safety and security, fine-tuning, things that are important certainly for a production-ready application. So there's tools here for development and also for your live system. So we will jump over to the workshop website. So this is the link that Jorge shared on the previous slide, copilotworkshop.com. We're using module 5. This is AI orchestration using Semantic Kernel. So I mentioned the prerequisites. This is a list of things you should set up if you're going to do the workshop yourself. There's development environment set up. You can do it locally, which I'll be doing. You can also use GitHub Codespaces, their development environment. Either way will work. There's instructions for that. And then there's the resources that I mentioned, the Azure AI Foundry, the connection to the Bing grounding, the model. There's a few specific settings for the model, and so on. So that's all set up already, and we'll just jump into the application. So if you go to GitHub, you can clone the repository locally and open it in Visual Studio or Visual Studio Code. So we have 6 lessons we'll walk through. They get increasingly more interesting and complex as we go, but the instructions tell us what to do here. So first, we have a console app, and it is going to have a semantic kernel, which we will use to interact with our LLM. So I have as I said, an OpenAI GPT-4 model deployed, and we will set up the kernel and then system prompt. So system prompt is where you tell the chatbot what it's going to do, and maybe more importantly, what it's not going to do. So you are a friendly financial advisor that only emits financial advice in a creative and funny tone. All right, so you'll see as we interact with it that it should be adhering to that system prompt. We will pass that prompt along as an argument to the kernel, and then we will receive input and loop on that input until the user decides to type in quit. So you'll see there's a big loop here, and as long as it doesn't match this termination phrase, which is quit, we will keep running. So very simple console app, and we will run lesson 1 here. So you can just run .NET run. It'll build the code and execute it. All right, so we have our user prompt, and I could start by asking, what kind of chatbot are you? And it'll take a second to think. Well, hello there. I'm your zany, wacky, and wildly accurate financial advisor chatbot, and so on. Lots of emojis sprinkled in for good measure. So it sounds like it's following what we told it to do. Now, if we stray outside of the system prompt, if I say, what's the weather usually like in Mumbai in February, what's it going to do? So it has no problem answering that. It says Mumbai gives you a delightful break from its usual sweltering heat, etc. So we can actually change the system prompt here. We can say, if you are asked about other topics, don't respond. So this restricts it to being strictly for finance. So let's quit. We will run it again, and we'll ask it again what the weather usually like in February. And this time it says, I'm not a meteorologist. Here's a money tip instead. So it found a creative way to say, no, I'm not going to answer your question. So this is really important. We talk a lot at Microsoft about responsible AI, putting guardrails on AI. There's many reasons why you might want to do that. Certainly, we don't want it to be suggesting anything illegal, anything harmful. We want to make sure it's not saying anything detrimental to, if you're putting this out for your customers to use, you don't want it to say anything detrimental about the company. Or, there was a kind of a story where car dealerships, someone tricked the chatbot into offering a car for only $1. You have to put guardrails in place to keep the AI from doing something detrimental there. So this is one way to do that. Certainly the grounding that we'll show later is another layer of defense. But just wanted to show that that's how you set up a simple chatbot and put some guardrails on it. This chatbot right now does not actually have any history enabled, so it does not remember from one prompt to another what has been said. So if I say, please address me as Adrian, knows that. Okay, and then if I ask it, what's my name? Oh, I wish I had a crystal ball for names. So it doesn't remember. So we're going to move on to lesson 2, where we add in some history. So these lessons are in different directories in the repository. They all kind of start where the prior one left off. So step 1 here is kind of building on the end of lesson 1. So we're bringing in a new namespace reference for chat completion, and we will create a chat history object. And that contains the prompt, so we can actually get rid of the code here for newing up that kernel. So we have the same prompt or same system message as before, and we've created a chat history. And then it says to remove the other code, and then we need to start building our chat history. So when the user enters some user input, we're going to add that to the chat history object. And then when the assistant responds, we can add that to the history as well. So you can see chat history.add assistant message, chat history.add user message. All right, so let's quit lesson 1. We'll jump over to lesson 2 and run that. And we'll say, what kind of a chatbot are you? It should come back with the same thing, friendly financial wizard. All right, let's try an example that's a little more finance related. So I could say, I don't like investing in bonds. They're super boring. Please don't recommend bonds. All right, so it's gonna acknowledge that. And then if I say, what kind of a portfolio should I use for retirement? It says stocks, bonds. So it did mention bonds, but it says, okay, I know you're not a bond enthusiast, but think of these as the bass guitar. They keep things steady and grounded. So it at least remembered that I said I don't like bonds, which that's just something I made up. But you can see that the chat history is working. It remembers from one prompt to the next what has been said. So that's lesson 2. We'll go on to lesson 3. This is where it starts to get more interesting with Semantic Kernel, adding in some plugins. So as Jorge mentioned, LLMs are trained on massive amounts of data. They can do wildly complicated things, but they can't do some very simple things like tell you the current date. They're just trained on data that has been gathered from many sources, but they don't necessarily have access to real-time information. So if I go to, if I run this again, and I ask it today's date, it'll probably say something witty about how it doesn't do that kind of thing. Yeah, so it is good up through October 2023, but anything beyond that, it doesn't know what to do. So lesson 3, we're going to add this plugin. So this plugin actually already exists in the code base. I won't take the time to recreate it, but essentially we're decorating it with this kernel function attribute that tells the kernel that it can run this function when it needs to get some information about the date. And it uses this description, this natural language description, to decide when to use this function. So it retrieves the current time in UTC. So the kernel will use that natural language description to decide when to run this function, and it will implement this very simple statement grabbing the UTC date time. So we just need to make our kernel aware of that. So let's jump over to lesson 3 here. And then we need to add the plugin. It's very simple. We just new up a plugin object and add it to the kernel. And then we need to tell it when to invoke that function. Jorge mentioned this briefly. This auto invoke will tell it you have free reign to invoke that function whenever you think you need to. So there are some other options there, but this is kind of the most permissive one, letting it run that function whenever it thinks it makes sense. And then we will update our code that actually invokes the chat bot here to use the new settings. And that should be good. I think we can run it now. Yeah. So we will jump over to lesson 3, .NET Run, and say, what is today's date? Boom, February 25th, 2025. I also want to show that there are some features for tracing what Semantic Kernel is doing. I'll copy this from, you'll see that there's a solutions directory that has all the completed solutions in case that's helpful for reference. I'll be working under lessons, which is starting with kind of the bare bones and adding the code to it. But I will add a couple more using statements here, and then I'll enable tracing, and we'll see what that does. So we need to add this before we build the kernel, otherwise it won't work. And let's try it again. So we should see a little more kind of verbose logging from Semantic Kernel here to tell us what it's doing. All right, we can see it already here. So this is telling us that it's going to invoke that plugin. It's going to invoke it. Here are the arguments. Invoking the plugin succeeded. Here's the result. So you can imagine, this is helpful for debugging. You're giving this thing free reign to just decide what to do. You want us to be able to see what it did in a log somewhere. So that's a very useful feature, turning on trace logging. Lesson 4, I'm going to skip over. That's just spitting out what the current plugins are that are registered. And there's not a lot of value in that. But I forgot, there's one other part to lesson 3. So we're going to add a second plugin for the stock information. So as Jorge mentioned, there's an interface here to a free API from polygon.io. And this plugin is going to have 2 functions that we can call. One is the stock price for a given symbol, and the other is stock price for a symbol on a given date. And again, we're giving it natural language descriptions for when to use these, and Semantic Kernel will decide based on the prompt which of these to use. So we'll pull in this plugin as well. I'm going to disable the tracing for now, just to keep things clean. This plugin is already in our code base. We just need to add it to the kernel. All right, that should be good to go. So let's quit this. .NET Run. All right, what's the stock price for Microsoft? All right. The stock price is currently $404. So it's using that plugin, and I could ask it, what was the stock price for Microsoft on the 1st of last year? It says it was hanging out around 376.04. All right, and just to see what it does, what will the stock price be on 1/1/2026? Predicting stock prices is trickier than nailing jelly to a wall. So it's creatively telling us it can't do that. So that's good. That's what we want it to say. And it looks like it's using all of those plugins that I added. So again, we'll skip over lesson 4. That's just showing an API where Semantic Kernel will tell you what plugins it has registered. And we'll get into lessons 5 and 6, which are agent-oriented. All right, so we're going to be looking at something called sentiment. If you're familiar with LLMs, you'll be aware that sentiment is the way that an AI can read a bunch of text, or even analyze other multimodal data sources and tell you generally what the feeling is. To look for key positive or negative words. This is really commonly used for like customer complaints or forum posts, things like that. We'll tell you generally what's the sentiment. Is it good? Is it bad? Is it in the middle? And so on. So if I just ask this, what's the stock sentiment for Microsoft? Stock sentiment for Microsoft is like trying to predict the mood of a cat. It can vary drastically. So it's basically trying to say, I don't know how to do that. So the agent should be able to help us do that. So we're going to first use a semantic kernel agent, and we need to pull in another namespace here. And I'm going to comment out the code that prints out the plugins. I'm going to uncomment some code that was commented out in lesson 4. And we're going to create the agent here. And I can explain what's going on with that. Add the code to create stock sentiment agent. Okay, so we're creating an agent and we're telling it what to do. Your responsibility is to find the stock sentiment for a given stock. Then we give it some rules to follow. So use a stock sentiment scale from 1 to 10, 1 for sell, 10 for buy. Give us a rating and tell us whether to buy, hold, or sell. Include the reasoning and the source of your sentiment. So that's the agent. Now we still need to invoke the agent. So inside our loop, we're going to have to do something slightly different. And that should be enough. And now we can run it. So let's quit lesson 3. We'll go over to lesson 5 and run that. So what's the stock sentiment on Microsoft? And the agent might take a little bit longer to come back, but that was still pretty quick. So it says 8 out of 10 buy, and market. It says it's using market trends and recent stock price data. Truthfully, it's using old market trends and the current stock price data. Maybe it went back a little bit to get older stock data, but this is not using analysis from financial analysts on the internet. This is doing a good job with the information it has available, but this is not fully grounded with the information from a search of the internet. So lesson 6 will add some more grounding for that. But I do want to demonstrate this is all our demo here has been entirely for a chat-based application. But if you wanted to build an API, you could tell it, be sure to respond with JSON. So let's try that. And we'll run that. And of course, because demos never quite work. Okay, so it is including it. It also included the full text, but here's a JSON payload, and we could set up a schema that the agent knows, and this could be something you return from an API. So that, if you've been wondering, what if I don't want to use a chat-based application? What if I want to have an API that my front end can call or my other applications can call? You can just tell the agent, use JSON in your response. All right, moving on to lesson 6. This is where we're going to add grounding so it can pull in information from the internet from stock analysts. And to use this, we have to use the Azure AI Foundry agent, not a semantic kernel agent, slightly different kind of agent. And again, this is all still in preview, but certainly strong enough that we can show it here. So we're going to pull in several new namespaces. We're going to be talking to Azure AI projects. That's the project I showed you in the Foundry. Azure Identity lets us authenticate, and this namespace lets Semantic Kernel talk specifically to Azure AI agents. And we'll have kind of a bigger chunk of code here pulling in the Azure Foundry project and the Bing connection. So we are going out to the Azure AI Foundry and getting a reference to that project that I created, a reference to the Bing grounding connection. We're going to create an object with that Bing grounding tool so we can pass it to the agent and say, hey, make sure you make use of this grounding feature. And here we'll create the agent. We're going to tell it which model to use. So I could have any number of models deployed. I just have one out there right now, but I do need to give it the name so that it knows which one to use. And then we give it the same kind of instructions, and we give it this Bing grounding tool. Now, we don't have to give it any tools. If we didn't give it these tools, it would probably behave just like the other agent did. But with this Bing grounding tool, it will go out and get information from analysts. In fact, we say only use current data from reputable sources such as Yahoo Finance, MarketWatch, Fidelity, and similar. So that's creating the agent. And then we need to invoke the agent, and we can run the test. All right, so we still have our chat history. We're talking to our agent, and we're spitting out whatever it gives us, and so on. So let's go ahead and run this. All right,
hey, Adrian, would you like to take, there are a couple of questions, or you want to wait?
Yeah, go ahead. Sorry, I wasn't looking at questions. Would it always come back with the same JSON structure given different symbols? So it should, like you could give it a JSON structure to use ahead of time, and it should adhere to that. Jorge, is there anything you want to add to that about the JSON formatting?
I put in my comments, but I don't know if those are coming through the, you can, if you, exactly. You have to give very specific instructions. So two ways to do it. Either providing a specific JSON schema, like and say only responding JSON using this JSON structure. It usually works providing a sample JSON response as well. But yeah, the more explicit you are, it will ensure that's always consistent.
Okay. So on the lesson 6 demo here, what's the stock sentiment for Microsoft? And this has to go out on Bing search to many sources. This takes a little bit longer, but it came back pretty quickly here. So it gave us its source. It used Forbes as its source, and it gave us a actual reference. So based on its current analysis, it shows a strong operating performance, 8 out of 10, and it gives us its reasoning here. So clearly this has gone beyond just looking at the stock price. It's gone out onto the web to look at what analysts are saying, and it's given us that as well. So this is using the power of the LLM plus the grounding from the current information online, which is a pretty cool thing. So that covers lessons 1 through 6. I will also show the deployed application in Azure Container Apps as well. I don't see any other questions, so I'll jump into that.
There was a question for a link to the samples. I put it on YouTube. I don't know if it came across. It seems like comments with links are not being shared, but it's essentially copilotwksp.com. So for Copilot Workspace, but workshop abbreviated. So that's it's module 5, and that's where you can, that's what there's a link to the GitHub repo from there as well.
Okay, thanks, Jorge. So going back to Azure AI Foundry, or Azure Portal, we have, with the code that is in the repo, we have an Azure Container App with bicep templates to deploy the resources that we need. And I've run that using the Azure Developer CLI, as Jorge mentioned earlier. And that has deployed a bunch of resources. You can see there's 2 container apps here. One is a front end, and one is the back end API. We also have some other supporting services like App Insights, Container Registry, Shared Dashboard, and so on. And then we also have a managed identity. So this is an identity with some specific privileges that we need to be able to talk to the Bing grounding resource and the Foundry project. So you'll see here we have this Azure ML Data Scientist role. So that allows my user in the CLI context has those permissions, and in the Azure Container Apps context uses this role to be able to access those APIs. So if we go to the API container, we can browse that. You'll see this is just a .NET API with Swagger. We can interact here, give it a message to send to the LLM. We can also go to the front-end container, and we see the same system prompt, your friendly financial advisor. We can ask it, what's the stock? Oh, let's ask, what's the stock price for Microsoft? This should come back in a few seconds. It has to spin up from a cold start, so it might take a little longer.
Did you click? Because I don't think enter. Oh, you did. Okay.
Yep. Yeah, so that's working. And then what's the sentiment on Microsoft stock? And this one, again, can take a little longer as it goes out over the internet to collect all the information and summarize it. But it should come back here in the same window.
And so that's the one that's using grounding with Bing, so it's going out to the search. And
yeah, there we go. Gives us its sources and everything. So so that's the front end application, and we've talked about all the lessons, and that covers everything that I had. Jorge, is there anything else you wanted to demonstrate?
No, I mean, there is obviously there's a lot more capabilities that are provided by Semantic Kernel, like for instance around observability. If you need to troubleshoot like tracing, it's an option. So that all of that is available. I mean, if you go to like the link aks.ms/sk/learn, it takes you to the Microsoft Learn, or I mean, you can just Google it and it will take you. And there's many more examples out there. So definitely take a look at there. Yeah, so I see a couple of questions on the chat, and actually I see another one on human interaction. So I did take a look at that one. So the example that we have for working with agents is actually it's only collaborating between two agents. So we don't have an example where it's actually going across for human interaction. And it turns out there is a GitHub issue where this was requested, and the last update is that it doesn't look like it made it to the last release, but it is in the works. So it will let you just add that human interaction as well. And another question about grounding. So configuration in Foundry. So the grounding, the reason why we did that configuration in Foundry is because there's a little bit of history there, because we initially did this demo with a resource called Bing Search, and we were purely doing this straight with Semantic Kernel agents. There's currently a restriction on the Bing Search resource. There's I guess the product team wants us to use the grounding with Bing Search resource, and it makes sense. I mean, from an AI standpoint, that you want to limit it, and that's the notion of grounding. In that resource currently today, it's not compatible with Semantic Kernel agents, but it is compatible with the Azure AI Foundry agents, and that's why we had to use. And Semantic Kernel is compatible with Azure AI agents, so it's kind of like three things combined. But yeah, to create resources for those for Azure AI, you can do it via bicep templates. We just didn't get I mean, that's in a kind of like on to-do. We didn't get a time to build that programmatically, but we do provide you, if you go to that Copilot workshop site, there are instructions on the prerequisites that will guide you how to create all of these resources. And those are actually prerequisites for the lessons. So you have to create them ahead of time, and then you can start the lessons. But yeah, ideally, if the bicep solution should deploy all the resources, but it's not quite there finished yet.
Yeah, and it depends on how you look at grounding. So I think the stock prices and current date time is actually grounding. It's just a different type of grounding. And the Bing search is kind of a more general grounding using whatever's on the internet. So you can accomplish grounding using plugins for sure. It just depends on what kind of grounding you're doing.
And then so the next question is whether there are other computer products, and yeah, that's a good one. So the one that I think it's very probably more known than Semantic Kernel is LangChain. I think that's probably the most similar one. It has similar I mean, I personally don't have much experience with LangChain, but from what I've seen on like just doing from the simple demos, it does have very similar concepts. So yeah, LangChain, and LangChain works with Azure AI products, so it's not necessarily, I wouldn't call it a competing product. It's just a similar SDK, a similar framework, right? The idea is if you want to leverage AI services, I mean, obviously, yeah, what makes money for Microsoft is using the Azure AI, OpenAI, and the Azure AI services. But the framework itself, I mean, we have a lot of tutorials how, if you want to use LangChain with Azure AI, many examples. So yeah, similar capabilities. I think from what I read is Semantic Kernel is maybe a little more like production grade, like in terms of the observability aspects and to taking an application to production may have better capabilities there. But yeah, LangChain also works great with Python as well. That's what I've seen it used a lot. And yeah, I mean Node.js as well.
All right. Are there any other questions? We just have about 5 minutes left here. If not, Bala, we'll pass it back to you.
Thank you very much for taking your time. It was a pleasure hosting you both. I believe there is one last question. Or let's see. Yep, it's just okay. I appreciate everyone joining us today, and thank you. And we'll see you again next month with another wonderful topic. Thanks all.
All right. Thank you.
Yeah.
Thank you.